This video is on normal distributions and bell curves. Here we have a normal distribution, and on normal distributions the graphs are symmetrical about the line here, which is the mean of the data. And then for every standard deviation you go out, we'll have a line representing going out one standard deviation on the graph. So the first line is one standard deviation out, and then the second one would be 2 out. And then the third line, almost at the very end of the graph, is 3 standard deviations out. And then we do this on both sides. So you would write this as x bar, which is the mean, plus 1 standard deviation, and then the mean plus 2 standard deviations, and then the mean plus 3 standard deviations. And then you would write these in on the other sides too, except for on this side you use minus because we're going down from the mean. And then we use a rule to find the percentages of data. It's called the 68, 95, 99.7 rule. And so 68% of the data is going to fall between the first 2 standard deviations out, and so 68 over 2 is 34, so in each one there's 34% of the data. And then the second 2 standard deviations out each have 13.5% of the data. And then in the last 2 standard deviations out on the really far edges, there's 2.35% of the data in both sides. So we can use this in problems where we're trying to find what percent of, like, for example, what percent of students would fall between a certain height range. So now we're going to have a few example problems. Alright, now our example problem has, so say there are students in a class, in a 6th grade class, and the mean average height for students is 60 inches, and then the standard deviation for height is going to be 5 inches. So what percent of the students' heights fall between 55 and 70 inches is our problem. So let's first find out how many standard deviations out from 60, 55 is. So 60 minus 1 standard deviation, which is 5, is equal to 55. So that's 1 standard deviation out going down. And so that would be the mean minus 1 standard deviation. And then for the going up, we'd have to do 60 plus 5 plus 5, so plus 2 standard deviations is equal to 70. And so that would mean it would be the mean plus 2 standard deviations. So if we know that we're going out 2 standard deviations and then 1 on the bottom, we can scroll back up to our graph, and then here we have the showing percents. We have 34% in 1 standard deviation out going to the top, and 13.5% more if you go out 2. So that would mean we'd know for going up, we need for adding, when we have the mean plus 2 standard deviations, that's going to be plus 34 plus 13.5. And then we also have to go up, though, and see, since we're going down, when you go down under standard deviation, that's 34 also. So then we'll add that to our equation, and we'll have 34 plus 13.5 is equal to, and then that's going to be 68, 71.5. So 71.5% of the students fall between 55 and 70 inches.
z-score to find the percent on a calculator. So the z-score is the number of standard deviations above or below the mean. So if the standard deviation isn't always 1 or 2, we need to know how to find out the percent. So the z-score, or z, is equal to the x value, or whatever the value is, minus the mean, and that's over the standard deviation. So let's use a practice problem. So in Hira's class, the mean for the shoe size is 7.35 in women's shoes. And Hira's shoe size is 6. So let me write Hira's, and that equals 6. And the standard deviation is 1.25. So we can use a calculator to calculate what is a percent. So first we need to find the z-score, which is z equals, so the x value is 6 minus 7.35, and that is over 1.25. So we get that the z-score is 1.08, or negative 1.08. So on the first thing that you do on a calculator is, so the first thing on you want to do on a calculator is hit second vars. So once you do that, you should get to a screen like this. So after that, you want to go over to draw, and you'll get to a screen like this, and you want to select shade norm, or shade normal. And then you'll end up at a screen like this. So we have the lower bound, the upper bound, this is the mean, this is standard deviation. So we will always want, most of the time we want our lower bound to be negative infinity, but we want the upper bound to be our z-score. So we're going to put negative 1.08 for our upper. So once we do that, we want to go ahead and hit draw. And you should get a bell curve on your screen that looks like this. So we wanted to find out what percentage of the class has their feet smaller than Hira's feet. So by doing that, we find the area is 0.14, which is about 14%. Let me just get that. Yeah. So the area is 14%. It shaded the only part of the bell curve that we want to find, so that's 14%. So our answer is 14% for number 1. So let's do another problem here. One where instead of finding the amount of feet smaller, we want to find the amount of feet that are bigger. So Tahira has a shoe size of 7. So her shoe size is 7. And so we already know that the mean is 7.35, and the standard deviation is equal to 1.25. So we find the z-score, which is 7 minus 7.35. That is over 1.25. We find that our z-score is equal to minus 0.28. So we want to find out what percentage of kids have their feet bigger than Tahira's feet. So this negative 0.28, that's minus 0.28 standard deviations from the mean. So again, we want to go back to our calculator, enter our upper bound as negative 0.28, and get a curve that is like this. So we find that the area is about 0.39. So, but that is a percentage of feet smaller because it's going down. So we want to find the other side of the bell curve. So what we're going to do you can subtract. So you can do 1 minus 0.39. Well, that's what it's about. And you get about, let me just fix that. And you get about 0.61. So that's about 61%. So another way to find this, or what I think it's also faster, is to switch the upper and the lower. So we want now the upper to be infinity, and we want the lower to be minus 0.28. And that gives us the amount more than the amount of standard deviations. So we're going to enter infinity as our upper and minus 0.28. We do this one E99, that's infinity, because the calculation don't have an infinity key. So now we do that, and we should get a graph looking like this. And it says that the area is 0.61, and that's what we got. It's 61%. So both ways you can do. I just showed you how to use the z-scores to calculate the percent of the data.
Parker and
Zane.
thanks for watching. Okay, what do I want to have everything get sucked into the hole. Alright, so let's
It's
just...
recording. Did that just catch us fighting on video? That fight scene was lame.
That kind of reminded me of a certain other video where the people were arguing about how to end it.
Shut up, Parker.